Okay friends, welcome to part 3 of our video presentation on business intelligence. In part 2 I give you a brief overview of the major components of areas of BI architecture. So now with subsequent video presentations we'll try to get into more details about each of these parts that we already discussed. Now a few ideas about the source systems. Now where do organizations get their data from? What are their typical sources? Typically it works something like this. There is an organizational pain, for example, some kind of organizational need or organizational problem that motivates BI. For example, one of the concerns being faced by a university could be low level of retention in certain programs. Now this pain leads to business requirements. For example, something needs to be done about this organizational problem, something specific, retention needs to be improved. So because of that, the organization decides to create a BI application, some kind of business intelligence application that would help address this organizational pain. And naturally, this BI application would need some kind of data, right? So this is how data sources are born. So let's say a university starts keeping track of those students who are at risk, who are at risk of dropping out from a particular program. So they create a specialized database to monitor and keep track of those students. Now, depending on the application that you need and depending on the organization involved in BI, you may have a single source system, meaning just one single database is used, or some BI applications may require hundreds of sources, hundreds of databases or file systems, that fit into a particular BI application. Now, a variety of sources can be used a variety of data sources can be used for business intelligence. Data can come from ERPs, enterprise resource planning systems. Data can also come from the web. Data can also be acquired from third parties. For example, data about customer demographic data in a particular region. And also data can come from sensors, let's say RFID tags, that are used for identifying flow of inventory in a warehouse, and much more. And also this data may involve different platforms, in different formats. So that kind of gives you an idea that data integration, this particular task is not an easy task, because integrating data from different sources using different platforms and using different representational format can be quite challenging. So once sources of data are identified or created, typically there needs to be some kind of data cleaning or data audit before this data is integrated. Now the problem is that many source systems have been around and they have been used for many years, and because of that they contain a lot of bad data, for example missing or simply incorrect values, and overall because they have been used for so long they can be poorly documented. Whatever was changed in the past to those data sources, all this information sometimes is lost. Organizations sometimes use the so-called data profiling software to help them understand better their data sources and improve quality of their data sources. Now, this profiling software can generate statistics on missing data. It can also do search for primary and foreign keys to get a better sense of the structure of the data. It can also reveal how certain derived values are calculated, based on analysis of other components. But sometimes, there's no way around using a human subject specialist. For example, somebody who is knowledgeable in human resources and the kind of procedures used by the human resource department, so that they can explain to you what the data contained in a particular data source is all about. So overall, the kind of value chain, the kind of procedure that is used to get data and transform it and input into a particular data warehouse is represented with the acronym ETL. So basically the data needs to be extracted from somewhere, then it needs to be transformed, meaning it needs to be cleaned, it needs to be organized better, and then it needs to be loaded into a data mart or a data warehouse. Now data extraction can be performed manually. It can also be performed using some kind of code, let's say SQL code or SQL queries. There are a lot of commercial data integration software. Again, the kind of software that you use depends on the kind of data that you have and the type of application. For example, there can be middleware that helps companies integrate RFID data with their SAP ERP system. I know there's a company called Shipcom Wireless, and they are very famous. They are quite known for their catamaran integration software or middleware that helps companies integrate data streams coming from RFID tags and barcodes with their ERP system. And then data is loaded into warehouse during a load window. So load window is the duration of time that is specifically used for loading or updating a particular element of a data warehouse. Now, organizing data. Now, one way to organize data for a specific BI application is to use an independent data mart. Now, independent data mart means just like a standalone database or standalone repository of data for one specific business intelligence application. Now, this approach to just have one single data mart, one independent data mart that doesn't depend on anything, has a number of advantages. In a way, it is easy to create because you don't have to think much about the overall architecture used for data storage. You just create one single database, and it can also be quite effective when it comes to meeting local needs, the needs of a specific employee or a specific department. However, there are some disadvantages in that approach as well. Well, first of all, independent data marts, when they're not dependent on one central location, they do not provide a single version of the truth. So the kind of information contained in those data marts can be quite different and contradictory. Now, actually, I wrote a case about this, and this case is fictional, but it's very parallel, to my actual real-world experience with some of the companies in the UAE. Now, like just one specific example of absence of single version of the truth. In the UAE, they use English sometimes to transliterate Arabic names. Right, so if you take like an Arabic name, let's say Muhammad, if you try to translate, when different departments try to write down the name Muhammad, they will use different spelling in English. Sometimes it will be spelled with one M, sometimes it's spelled with double M, sometimes it's spelled with U, MU. Muhammad starts with MU. Sometimes it's spelled with A. So sometimes when organizations have different databases for clients, they will spell the same kind of name of the same person, Muhammad, in different ways. And sometimes it gets to the point where, like, let's say, marketing department and accounting department, they have two records for somebody named Muhammad, but, they're not sure whether it's the same person or different people because the spelling is different, some data is different. So the question becomes, which one is the truth? Which record actually represents the truth? Okay? And then, of course, there will be inconsistent data definitions and inconsistent dimensions. People will be using different conventions, different way of calculating certain values. So all this can lead to confusion. And although I said that it can be easy to create, later on it can lead to all kinds of problems. And those standalone independent data marts can be very expensive to maintain and update because there's a lot of confusion, and the overall organization was not very rigid, was not very robust in the first place. But of course, dependent data marts are common, and since approximately late 1980s, companies began to develop two approaches to data warehousing architecture. Now, the first approach is called Enterprise Data Warehouse, and it was developed by somebody named Bill Inman. The second approach is called Data Mart Bus Architecture, and it was developed by somebody named Ralph Kimball. So this person has a website as well. And then there's a third type. It's called Federated Architecture, Federated Approach to Storing Data. Now, this approach was not developed by anyone in particular. It was developed by life itself. Typically, federated approach to storing data, emerges when two companies, they merge together. Let's say Hewlett-Packard buys Compaq. Now, because both companies have existing databases and existing decision support systems, and it's very expensive, if not impossible, to rebuild everything from scratch, so that the two companies that are merging together have one unified infrastructure. Because it's not possible, companies just do whatever it's possible to somehow integrate or link those databases together. So typically it's done with some kind of middleware. Okay, so those are like kind of solutions that are dictated by life, because some people argue that it's impossible to do it any other way. Now, there is a disagreement up to now which architecture is the best, and most of the disagreement is between Enterprise Data Warehouse approach and the Data Mart Bus approach. So we'll talk about each of those approaches briefly, but mostly about enterprise data warehouse and the data mart bus architecture approach. Now, how things work under enterprise data warehouse architecture. Now, just like a few ideas before I show you a diagram that seems to explain pretty much everything. Enterprise data warehouse model starts with an enterprise level of analysis of data requirements. Like what is required from an organizational standpoint? What kind of information needs to be stored to meet organizational data needs? So that's the kind of analysis that is performed here. Now, special attention is given to building under this paradigm, under this architecture. Special attention is given to building a scalable infrastructure. Meaning, if things change, if needs for data storage change, or if the company becomes bigger, and there's increased demand for storage capacity, the designers want to make sure that the architecture can accommodate that. And then architecture is developed in an iterative manner, meaning one subject area at a time. Let's say first you create a storage area for marketing data, then for sales data, then for accounting data, then for finance data. And data is stored in the warehouse in the so-called third normal form. Now, dependent data marts are created from that single source data from the warehouse. Now, the dependent marts can be either physical, meaning it's a separate physical box or server, or they can be logical, meaning like they're just like some kind of logical area within a centralized warehouse that is used by a particular department. The dependent data marts can be developed for specific departments, functional areas, or specific purposes, or specific employees, and then we use different data models depending on the specific BI applications that they have. Now, because dependent data marts obtain their data from a warehouse, a single version of the truth is maintained. So we know like what is the true value of a particular field. Now, it was mentioned that dependent data marts often store data in the so-called multidimensional or star schema format. I'll show you in a second how this format looks like. With this data model, fact tables store numerical values, for example, units sold, and dimensional tables, they store measures that are used to qualify the query. So basically, like you can say that dimension tables, they kind of provide further details for those numerical values. And then querying can be done across those dimensions. Now, the data model looks very much like a star, and I'm talking about like visual representation. And the multidimensional model, they're very parallel to how people think about business issues and life in general, right? So this is how a star schema looks like. So you have a fact table, let's say a table that stores information about claims. And the kind of information is stored includes physician ID, the ID of the doctor responsible for that particular claim, patient ID in relation to which patient a particular medical insurance claim was made, and so forth. And then, those values from the fact table are elaborated by the dimensions table. For example, patient ID is taken from that table that contains patient ID, but also other additional information about the patient. And overall, this kind of approach is called, looks similar to a star, right? Because you have a center and then you have like those branches coming from the center, just like a star. One thing worth mentioning or reiterating is that this approach is natural to human thinking, because humans, they don't think like computers. They don't think in terms of specific instructions line by line. Humans tend to think about things and concepts organically. So, for example, when people brainstorm about the storage needs, they'll say, oh yeah, we need to store data about claims, okay? And then they will say, well, in relation to claims, we also need to store data about patients, right? And then let's say they will say, well, in relation to patient, we also need to store information about insurance, so there will be another branch. So this kind of organic branching out way of thinking and brainstorming seems to be natural, seems to be organic for humans. And then, it's also like robust, because if something happens later on, there's a new table that needs to be stored, then we can add the table and link it to appropriate tables that already exist. So that's the nature of that star schema and the kind of philosophy being employed here. Now, bus architecture uses a slightly different approach. I would say it's like it's an approach that in a way seems to be more efficient, but also seems to be a bit more tedious, because it requires a lot of prior planning, something that an organization may or may not be able to do. Again, don't worry about those specific ideas. I'll just go through them, and then I'll show you an image on the next slide that seems to explain pretty much everything. So building a bus architecture involves identification of the specific business processes and the kind of data requirements that they have. For example, organization may figure out that the kind of dimensions or data requirements for processes may involve information about orders, deliveries, customer calls, or billings, right? Or those things can be processes. And then single business process is supported by specific dimensions of that data, and those dimensions are called conform dimensions or common dimensions. And then additional data marts develop using those conformed or common dimensions. Now, under this approach, there is no central data warehouse with normalized data. All data is stored in individual data marts. However, because those dimensions are common, there is a degree of standardization, and one can, write queries that rapidly search across all those different dimensions. Okay. Now, I know those ideas may be like a bit, too high level, but I think this diagram kind of explains it all. So basically, within an organization, you have the following processes that are listed here. Okay. And through analysis, it may be determined that all those processes use the following common dimensions or data areas. Let's say they use information about date, about product, about warehouse, about store, about promotion, customer, and employee. For example, the process of making retail sales, meaning making sales in a particular store or retail location, involves usage of the following dimensions or data components. You need to store information about date, when a particular sale was made, also about the product for which the sale is made, also, let's say, the specific store where the product is sold, the specific promotion that was used to generate that sale, also information about customer who bought that product, and also information about the employee who made that particular sale. Okay, so all those dimensions are used for this specific process. Now, for a different process such as retail sales forecast, you're only using 3 dimensions. Using information about stores, about products, and also dates. Okay, so this is data mart bus architecture, and in a way, it's like a bus, right, where each process uses specific dimensions from that kind of line or bus. Okay, so this is how it's organized. Now I would say, like, it also, this approach has also some advantages because it seems to be very efficient. At the same time, it also seems to be organic, where new dimensions can be added, and that's why the debate as to which architecture is better, it continues to this day. And then the third form is the so-called federated architecture, and I kind of explained it already. It basically leaves existing decision support structures like operational systems, data marts, warehouses in place. It does not thrive to integrate this existing decision support environment into a single integrated solution. Typically, it happens during acquisitions or mergers when 2 companies with existing BI infrastructures, they join their forces and they start acting as one single enterprise. The data is either logically or physically integrating using shared keys, global metadata, distributed queries, enterprise information integration, or other methods. But commonly, you can say like middleware, some kind of software that pulls everything together. And then, it may be a messy solution because sometimes you have to integrate together databases that have different structure, different technologies, different metadata. But some are saying that this is a realistic solution to those kind of situations where 2 companies need to be merged or integrated together, because it's unrealistic to kind of rebuild those 2 infrastructures into one from scratch, because it will cost too much money, it will take too much time. And it may also be impossible because it will create so much disturbance to existing operations of those companies that it will be technically impossible. Okay, friends. So this concludes part 3 of our video presentation on business intelligence. Thank you for listening.